now we're going to start talking about how you start looking at your alternatives, right? So if you recall, when we laid this out, there's existing conditions assessment to understand trends and understand if safety needs to be in your purpose and need. And then there's, well, how do we evaluate alternatives? And so we're changing gears into that set of tools. And today we'll talk about crash modification factors, and tomorrow we'll talk about the predictive method. So crash modification factors, we're going to define them and start talking about how to apply them, and start to, as I said at some point, I think, you know, in using CMFs, the devil's in the details. And so there's a lot of details to consider, and we're going to start talking about those to at least prime the pump in your thinking. And then we're going to identify resources for CMFs. And there is a Mentimeter, and I'm betting you, let's see, I need to get to the most, what's the, what slide number are we on, Rob?
We are on,
I am not at the most recent.
we're on 21.
Sorry about that.
Yeah, so you gotta.
There we go. Oh.
So keep going.
Trying to get out of the, yeah.
Just keep flipping forward. Get to 21.
Oops, I passed it.
Yes.
No cheating. Okay. So we're talking about crash modification factors. How familiar are you? You guys were chomping at the bit to start answering.
Pretty even.
Yeah. Okay, so pretty even split. Hopefully we get a little for everyone. Fundamentally, we want to sort of give you insights as to what to think about when, what they are, and then what to think about when using them. So what are they? CMF stands for crash modification factor, and it quantifies the change in average crash frequency you would expect that could be attributed to a treatment. And we use the word treatment and countermeasure interchangeably. And so a CMF is a factor. It's a multiplicative factor that says, and it looks like this first row here. And so in this case, the CMF is 0.58. And now CMFs are, we used to call them crash reduction factors and CRFs, and specify them as percentages, so 42% in that second row. It's just one minus the other. We talk about crash modification factors because not all treatments reduce crashes, so crash reduction factor could become a misnomer. So crash modification factor as that multiplicative factor in the first row there is the most common. There are also crash modification functions, and obviously that's in that third row there, that's an equation. And so you would input, in this case, your lane width, do the calculation, and you would get your crash modification factor. So they're just a number. And these numbers obviously have values, and that if they're less than 1, so that 0.58 that I just showed you, that means they will reduce crashes, because again, it's multiplicative. If it's equal to 1, that means the treatment has no effect on crash frequency, severity, or type. It's not affecting safety. And if it's greater than 1, that means crashes would go up if you did whatever the treatment was. And some CMFs will have different different values for different crash types or different crash severities, mostly. Most CMFs will have different values for different types or severities. And there are cases where the CMF or the treatment might drive up PDO crashes and reduce angle crashes. So be aware of that. Now, this is where the details come in. So every CMF has a base condition, and that's the place where the CMF has no value, and it could be any one of these factors shown here: urban or rural, the traffic volume range, lane width, the roadway type, the shoulder width. But it's this condition in which the treatment has no effect. And when you're selecting countermeasures that we'll start talking about, you want to match that base condition to what your conditions are in order to start selecting the right countermeasure. And you want to select the treatment that might be influencing the crash type or the crash severity that you're considering. So you got to look at all these different factors to help you select the CMF. How do you use them? So as I said, they're multiplicative, and you could take that factor and multiply it against historic crash data, predicted crashes from just the safety performance functions, or expected crashes after you've applied the EB. Or you can you can just multiply, or you can just use the CMF and say, you know what, the CMF has a value of 0.58, so we would expect a 42% reduction between condition 1 and condition 2. So takeaway here is they're multiplicative and they can be applied to historic data or your predictions. And real simply, this is what it looks like to use one. We have 5 years of crash data for some situation somewhere, a lot of crashes. We have an average of 46.6 crashes per year. This CMF, whatever it might be, has a value of 0.96. And so we just take our CMF times our observed crashes without the treatment, this 46.6. So it's 0.96 times 46.6. We get 44.7 crashes per year afterwards, or 1.9 crashes per year reduction. Now, I'll talk for a moment about reporting. Well, I'll wait for that idea. So something to remember is, so I just said, okay, 1.9 crash per year reduction, and you're going to wind up with 44.7 crashes per year. Something to remember is CMFs are an estimated value, and so they're developed from doing before-after analyses, using statistical analysis from multiple sites and getting all the right characteristics of a before-after safety evaluation. And typically, those before-after safety evaluations yield a standard error, right? So the approximation of the standard deviation. And so you have to remember then that in fact, the CMF is that average value plus or minus some confidence interval. And typically we use a 95% confidence interval. So really, while this CMF for cable median barrier, is 0.71, there is a standard error, and when you kind of account for it and plan for that 95th percentile confidence interval, the CMF might range from 0.49 to 0.93. So that would have changed those results I just showed you. So, while it's great that we can grab them from the clearinghouse or the highway safety manual, it's important to remember they're developed from before-after safety effectiveness evaluations. There's going to be, the number we're using is the average. There's going to be a range to that for many, and it's developed as an independent factor for a specific treatment. So if your condition doesn't match that specific category, that base condition, you're not going to see that same result. So you have to be you want to be as careful as you can be in selecting countermeasures to before you apply them. So when you do apply them, most often it's you select one countermeasure, you apply it to your observed crashes or your predicted crashes, and you get your outcome. And now there are plenty of cases where you're doing multiple things at a location at the same time. Maybe you're adding a turn lane and changing the signal phasing. Or maybe you're adding a median and widening a shoulder, which would be great. Or maybe you're adding rumble strips and curve chevrons. And you want to, if you are applying multiple treatments, you can multiply the countermeasures for those treatments. So it would be CMF1 times CMF2 times observed crashes. The common practice right now is that they are multiplicative and that you multiply at most 3, and you want those 3 to be independent. So, and by independent, we mean affecting different crash types. So, I'm going to use my slide here to start talking about this. If there's a CMF for shoulder widening, and there are also CMFs for adding, this should say shoulder rumble strip, those two probably affect the same type of crashes. So they're probably not independent. So I wouldn't account for the benefits of both of those when estimating my future safety performance. I would pick the most conservative or the highest CMF to estimate my future safety performance. But this middle one, where I'm adding a left turn lane and changing my signal timing from permitted to protected, and I'm adding that leading pedestrian interval for the right turns where the pedestrians get to start crossing the street before the through movement, those are independent treatments. And so the CMF for adding a protected left turn phase, so we would get the safety benefit of both of those treatments. So in this case, I would multiply my CMFs. This one's a little harder if I have a curve and I'm adding curve chevrons and centerline rumble strips at that location. Are they independent? That one's a little harder. I would talk it through. I think my initial instinct would be I would select the most conservative instead of potentially overestimating my anticipated safety performance. So they're multiplicative. Right now, the guidance is 3 at most. Make sure they're independent. I will say that this guidance will be changing in the next edition of the Highway Safety Manual. And that manual will come out in the next year or two, hopefully, probably at least a year away. But anyway, so where do I get these? These are cool. I love them. I want to use them. Where do I get them? Part D of the manual, Part D of the Highway Safety Manual is essentially a big catalog of crash modification factors. Now, critical to remember here is the manual was published in 2010, which means the research stopped in like 2008, 2009, which means those are getting kind of old at this stage. An excellent resource, and probably most of you are familiar with this, is the FHWA CMF clearinghouse, and the web address is right here. Just go in, Google CMF clearinghouse, and that website has thousands of CMFs. It's updated quarterly. It will have multiple CMFs per treatment, and the CMFs are given a star rating, the treatments are given a star rating 1 to 5, and usually we like to use 3-star or better. Any of the CMFs that are in the Highway Safety Manual are 3 stars, so kind of 3-star or better is considered the threshold. If it's not in the manual and not in the clearinghouse, There is lots of published research. If you're going to use published research, you want to think about it in advance. Let's see, I probably talked about these slides. Let's see. So for the HSM, I think I talked about it. Well, critical to the HSM is Part D is that catalog. The next edition, it will become a how-to, and it's going to be an excellent resource of how to use them, how to estimate them, how to combine them, how to select them. So it's going to be a great resource. The other thing I didn't mention that's critical is there's a difference in the current edition of the Highway Safety Manual between the CMFs in Part C and the CMFs in Part D. And the CMFs in Part C are specific to those safety performance equations that you see in Part C. And we'll talk about this a little bit more tomorrow. And some of them are also in Part D, but those in Part C are to be used specifically with those SPFs. We're going to try and address that confusion with the second edition. The CMFs for Part C will be called adjustment factors. So a couple of nuggets about what is coming in the second edition. Let's see, I did talk through my slides. So the clearinghouse, thousands of them, updated regularly. It's a great resource. What I'm going to do now is show you what it looks like when you get in there. So if I can make it work, I'm going to go here to here. So I looked up a CMF in the clearinghouse. This happens to be about installing a lane, reallocating roadway cross section on a freeway to squeeze in a new lane. And when you look at it on the surface, you're like, wow, that's a really good CMF. It's 3 stars, all crash types, and the crash severities it addresses. So this is the kind of information you get. If you click through, you get a lot more information. So you get a little bit more about its scoring detail if you want. The standard error becomes available, which is valuable. They still are converting it to the crash reduction factor, so that's useful. And then some more information about the conditions in which this CMF was developed, which crash severities it applies to, the type, the number of lanes on the facility, there was a median, posted speed, urban, so you'd start to get a picture of where, what sites were used in the before-after evaluation of safety effectiveness. And then there's yet more information. Well, they had 400 sites. They were all in Texas. My goodness, a lot of site years of data. So a lot of good information in these details that you should look at when you're selecting. And then often you can click through yet further to an abstract of the study. And this is really helpful too also, because again, you can start to get an understanding of the context and the applicability of the CMF to your situation. So I encourage you when you are, you get into the clearinghouse and you get this, don't stop here. Your job is not done. Keep going and dig into it a little bit more to select. And you know, we're also showing, Rob will talk about this in a moment, but I'm making it look easy. You know, often when you go in there and you type in a treatment, you get 10, 12 CMFs per treatment. So there's a lot of work to be done here.
Or 60 or 100.
Research. What's that?
Or 60 or 100, but yes.
Or 60 or 100, yeah. And then published research is also available. And I would just say here, when you look at that research, try to use some of the criteria from the clearinghouse to evaluate that research. And then definitely it does require approval, you know, from your process to use that instead of any CMF from the clearinghouse or the manual. So again, I've been saying it over and over, but you know, the devil's in the details when you start selecting these. And there are errors in the clearinghouse. We've found a few. But you want to be sure that base condition for your site is consistent with the base condition for the treatment and CMF you're going to be selecting. So area type, facility type, volume range. You want to be sure that it's applicable to the crash type and severity that you're thinking about. If there's a standard error available, look at that. Sometimes the standard error is big enough where it might show that the CMF could increase crashes. Then what do you do? Take a look at how the CMF was developed, the star rating, if it's available, or the HSM. And these are things to document as well. And then think about independence. If they are independent, feel free to combine, but combine at most 3. And then, going back to our theme of documentation, what's important to document about CMFs? Think about it in terms of, if your reviewer was going to go try and find a CMF for whatever it is you're doing, that person should be able to more or less make his or her way straight to the CMF you selected. So the CMF, the treatment, the CMF value, and the standard error if it's available. The base condition, so kind of explain this is why we think it's a good selection. The source, if it's from the clearinghouse, each treatment and CMF has an ID number. Go ahead and include that. It makes it really easy to just say, the CMF of 0.58, CMF ID, whatever, 3 stars. And then what are the impacts and what are the caveats? There's always caveats. It's never as clear as I just made it look. Maybe there were no CMFs within your volume range, but your judgment says it's reasonable to use it. Well, then explain that. Or maybe there's no CMFs with the exact base condition, but for some reasons it matched based on this judgment. Document that. How to use them? Again, this is here for as you're starting to do this work. If you wanting to think about it a little bit, identify what are the treatments that we're applying. Go to the clearinghouse or the highway safety manual. What are the array of CMFs for my treatments? Select the CMF I want to use. Get my observed crash data. Understand the independence between my treatments. Narrow to my 3 or fewer independent CMFs. Do the multiplication. Report results.
I'm just going to linger there just for 1 minute. That you've said it several times.
Yeah.
I want to make sure folks understand. I mean, I have seen folks consider multiplying 3 CMFs that led to like 0.24, a CMF that's ultimately 0.24. It's unrealistic. And so it just what Beth said before about, well, I would probably choose the more conservative of the 2, and even though they may be independent, I'm gonna be careful. I don't want to overpredict. And so we can't emphasize enough that, often you don't want to use more than 1 or 2. 3 is kind of extreme. You try to. So anyway, I just want to reinforce that, Beth. You've said it several times. I want to make sure everybody knows that it can lead to the wrong answer and unrealistic answers. And
yeah, absolutely. So you can multiply this by, you could sort of do this method if you have crashes, observed crashes, and you want to report a number. You can also do the same exercise if you just want to report a % change. And this is, you can see it multiplied out. And again, be careful, proceed with caution here, because the results can get very optimistic. And Adam, it sounds like I might have spoke over you. Nope.
But there are at least two questions, one of which we need to circle back and pick up. So there are at least 2 things to talk about before the next slide, I think.
Okay.
The next slide is the slide I think it is. So the break slide.
Yeah, it is a break slide, so we can take a quick break, but okay. Questions?
Yeah, there were, so I guess anything else on this? Because they're kind of a different topic. They're looking back to some things we already talked about. Adam kind of fed them to me, and so I need to,
Go ahead. No.
Okay.
Go ahead.
So one is pretty straightforward, and the question came up, what if and you actually touched on this with CMS, what if the volume's out of range? So in the case study spreadsheet, if you try to type in 50,000 vehicles on that 2-lane rural, it's going to give you an error. So yeah, the safety performance functions and the crash modification factors are all developed with volume ranges, that the research used. So the research was based on, 4,000 to 16,000, and if you're outside of that range, the short answer is don't use it. But the longer answer is often you're looking at it, you're like, I don't have a choice. I have no other way. I mean, I have a choice. I can say I can't do this at all, and that sometimes is the right answer. Or if it, you've got 17,000 or 16,500, you're like, well, I'm just above the range. I think it'll give me the information I need to help inform the decision we're trying to make of should we go in this direction or not, and so sometimes you have to use your judgment. Now, if you're using the spreadsheets, they're set up to not go outside of those ranges. Same with IHSDM. IHSDM will error out, and just a forewarning, sometimes it happens and folks don't realize it's happening. You got to really look for the errors. And so know what those tools are doing for you, and sometimes you need to go off model. You just need to, the equations are available to all of us to use, and sometimes you have to kind of put it in a spreadsheet and have someone detail check it and say and document, this is the assumption, we were a little bit beyond the range, we thought it would be useful information, we calculated it anyway, here it is, here's the results, knowing it's out of the range of the research. I'm not encouraging that, I'm just saying that sometimes that is a project team decision to do that, because that information is better than having no information about a particular alternative. So I think I've over answered the question, but that's Beth, what do you think?
Well, I think you're right, and I think when in the scoping process, sometimes like a tabular summary of the model you're going to use, the data, the traffic volume you're going to use, and so on, and with the comments, caveats, concerns per row, so that at the very get-go, everyone agrees, yeah, the volume is out of range, but for this variety of reasons, we've selected it and it's okay. Because if you all agree to it up front, great, you're done. But it feels awful if you get to that endpoint review and somebody raises the valid concern of, hey, this volume is slightly out of the range, what do we do? So that's one of those scoping discussions that either, if you're preparing the outline of the method, take a look at it beforehand. If you're reviewing the outline of the method, ask, hey, is this in the range and what are we going to do about it?
Right, I would add that sometimes when something's out of range, you end up finding an alternative. Sometimes there's a better alternative than kind of forcing something that isn't intended for that purpose, and or bracketing the problem, saying, well, we're gonna solve it this way, we're gonna solve it this way, and then we're gonna bracket it. The prediction is between these points, and so there's a variety of techniques you can use to work through some of these methodology challenges for an approach that is just continuing to develop new information, on a weekly basis, on new CMFs and everything. So that's similar. That applies to the CMFs, applies to the SPFs. Another question was asked, and I think this was asked several times by several different folks about the safety ratio. And the safety ratio, I mentioned, I used the words the critical rate. It's looking at what the average is for a set of facilities, and then using statistics to determine kind of what a 95th percentile confidence upper and lower bound would be, and then is your crash rate kind of in that range or below, or usually you're looking for above that range. So if it's above that, then you can say 95% sure that this is above the statewide average for 4-lane undivided roadways. Okay, great. And we have used that, and it is still a valid and useful piece of information, still used for a lot of projects and studies. But it doesn't always properly account for regression to the mean. Beth showed the image with crashes going up and down each year, and which 5 years did you pick, and it doesn't always account necessarily as well as some of the safety performance functions for changes in the physical nature of the road. So you've got 4-lane undivided, but maybe the safety performance function accounts for some things that your average doesn't account for. It's based on a few pieces of information, and the safety performance function takes into account driveway, shoulders, whatever the pieces of information are, and it also separates intersections and segments, and it looks at it differently, and maybe in ways that the average rate you're working with might not. And so that's one way that the PSI can be better than the safety ratio. Again, I'm not saying don't use the safety ratio. I'm saying, to me, I have started kind of using the PSI more and more, because the second part of it is that when you truly do what we laid out, you are taking into account those historical crashes with empirical Bayes, another statistical process that takes that safety performance function based on a lot of the same roads you might be using for your average. It might be the very same roads, might be very similar data, and it's using that to develop this function, and then it's using the data and the calibration factor and everything, all the pieces, to give you kind of that expected number. That expected number is the number you're really trying to get to, and then compare it back to kind of predictions. So the PSI method takes into account actual data, and it, if you read the FHWA literature, it does it better than the safety ratio. They both do it to a certain extent, but one does it in a statistically more rigorous way. And so that's why we're proposing that, and a lot of folks are already familiar with the other method, so we didn't hit on that, but we certainly could touch on it tomorrow if there was a desire to do that. So Beth, I don't know, anything to add? Did that make sense? I don't have any visuals for that, so that's sorry. It's just I can, if somebody wants something, put something in chat. I can get a visual for tomorrow.
No, I think that's good from my perspective.
Okay. So, we'll be back in a few here.
Thank you.
Thank you all. Oh, and we're coming back to example problems, but not the case studies yet. So when we come back, we'll be diving in on some example work, just working through some kind of simulated real life examples of the things Beth has been talking about. So some of the complexities and how to overcome. See y'all in a few minutes. And let me go ahead and start in on the example problem for using CMFs. So this is using an intersection as an example problem for selecting and applying a CMF. And see, we've got a 4-lane undivided roadway here at the kind of center of a community, and there, so no east-west left turn lanes, and at the bottom of the screen there, 30 crashes in the last 5 years, urban, and many were opposing left turn crashes. So opposing left turn is left turn vehicle is turning and gets hit by an oncoming through vehicle. So you've got kind of related angle, but slightly different, but definitely related to the presence or absence of a turn lane. So we've done a little bit of digging, we've got some data, and we think this might be a solution. Maybe we want to put in this turn lane, which I've highlighted on the screen here. Maybe we need east-west left turn lanes at our signalized intersection. And small budget, we don't have a lot of time. We're not going to set up the whole predictive method here. We want to know what we think the crashes would be in the short term if we go ahead and do this as a spot improvement. We I'll create an unrealistic situation here. We have right of way, and we're going to go ahead and we can do this pretty inexpensively. We can restripe it. So or whatever the case may be. So we open up the HSM, we look on the clearinghouse, kind of do the things that Beth talked about, and what we come across is the HSM has a CMF of 0.81 for situations like this. However, and I forgot I had this on the slide, but the side street traffic exceeds the volume range. You know, it's never simple. And so okay, well, I got this good thing, right? It's right in the highway safety manual. It's published. It's the standard error is 0.1. It's kind of higher than I like, but it's okay. But then I look in the clearinghouse. Oh, and then the second one there is HSM CMF for newly signalized intersections. I think, oh, well, maybe that, you dig into that. No, that doesn't apply. That's only if, because I've got a signal. Yeah. So you're able to throw that one out, and then you look at the last one, the CMF for the clearinghouse, and it's 0.92. It's a bit higher. It's got a lower standard error, and so you decide, well, what am I going to do? And so here's kind of initial step, top line. Well, what are the ranges? The crashes, if I use the equation with standard error, 95th percentile confidence interval, I could end up with somewhere between 18 and 30 if I use the HSM CMF, the one from the manual, from the yellow book. And then if I use the clearinghouse one, I'm in the 24 to 32 range. But you kind of dig into it, you look at it, and you realize that the HSM, I mean, it is kind of it's the published guide. This is consistent with the crash data. We know that there are crashes occurring regularly, or not irregularly, right? It's crashes, but there are crashes occurring out there that we know are related to the absence of left turn lanes. And so we decide as a project team, we're going to use the highway safety manual equation. We know the side street's out of the volume range a little bit, but we think it's a good fit, it's a good match, and it would predict a reduction down to 24. So 30 times 0.81 is 24.3, and so a reduction of approximately a crash per year. And so now you've got some information to work with, and you could begin to do a benefit cost. If the project's going to cost X dollars, what's the societal benefit in the reduction of crashes? And I can start to compare those numbers. There will also be operational benefits, so potentially travel time, delay benefits that could be worked in there as well. But this is an important part of the equation. Often this is the largest part of the kind of benefit side of the equation, especially if they are opposing left turn crashes, which likely would have had a higher severity. And so it gives you the information to begin to make a project decision. Now, if you were uncomfortable, you could also look and you could give the team a range. We'll be somewhere from here to here. You could be more conservative, pick the other one. It's not always simple. We'll say sometimes I will tend to use the manual. Everyone's usually pretty comfortable with using the manual, and they don't debate that quite as much. So we're trying to paint a realistic picture here. This could very easily be a very real project, and you've got to make these kinds of decisions and then report back to the team what you found. Or if you're the project manager, make sure that someone is thinking these things through in a way that is meeting your needs for the project. And if you're scoping it out, you're scoping this out from the beginning that, hey, we need to, these are the kinds of things we need to be thinking about. And so this is where we need to end up here. And so we're gonna have to go through these steps, and we're gonna have to look at these things. So, all right, if you've got questions about that, I can certainly circle back. I'd like to press on to the next example, switch from an urban to a rural example. But certainly type in, and Adam is doing his best thing to keep up with questions as he's able. So the next example is alternating passing lanes. So we've got 13 miles of 2-lane highway with a high truck volume, and we have 200 predicted no-build crashes in the design year. So the prediction has been done, and it's 200 for the no-build, and you're considering a 2+1 design with some gaps over the 13 miles. So it won't be the whole way. There'll be, you know, kind of alternating third lanes, and then with some 2-lane sections in between them. So this is generally the setup, and you're asked to go and get a crash modification, you know, find a crash modification factor that applies for this. So you go into the clearinghouse, and there's several. And what do you use? You know, you've got I've got 4 shown here. I can go to the next slide, show kind of a little more information. That so you dig into the 4. You do what Beth said, and I will. You know, sometimes you end up you look at it, you do the digging, you realize you're still not totally sure. And there have been times when I literally pull the research. I mean, that's sometimes the only way to, and it depends how important. You know, if this is essential. Sometimes you pull the research and you find where the folks that are putting them into the clearinghouse got those numbers, so that you can make sure that you agree with that number. And so in this particular case, the first one applies to the entire corridor with and without added passing lanes, excludes crashes related to animals, intersections, and driver impairments. The second one applies to segments with added passing lanes only. As I discussed, this section doesn't have that. It's, you know, we're looking at the whole 13 miles, and it isn't passing lanes the whole way. So, and then the third one is Michigan study for passing relief lanes. The fourth one is literally a study out of Poland, and so didn't think it applied. So you end up saying, okay, we're going to use that top one. That is the most applicable number. It matches what we're doing, and we're going to dismiss the other 3. One is the wrong, kind of the wrong thing, the wrong project, and the other 2 don't. Well, they might apply in certain situations. They just don't apply here. And so we've got 0.68. You also see that it is the highest. It's conservative. It's the least reduction. And so, you know, that Michigan study was kind of the closest thing, and it's 0.67. So feel pretty good about we don't want to overestimate these benefits. And so we use the 0.68. And here is running through the calculations of how you would use that 0.68. You have 200 crashes in the first box. The next box, the crashes that are not applicable is 20, and that's animal, intersection, and impairment related. So you take out those 20 crashes. You're not going to be able to reduce those 20 crashes. And then so apply 180 crashes is kind of your new base. You multiply the 180 times 0.6. I feel like I should be using my spotlight here. So you use 180 times 0.68, and then you get 122. Bring that down, add back in your 20 crashes that you couldn't do anything about, and you end up with 142 and a 29% reduction in crashes. So your crash reduction is not going to be exactly what it would have been if you could have applied it to all of them. And I will say that is a very important concept. You always need to make sure that you understand what your CMF, what it applies to, how it was developed, and what it applies to, and that you don't apply it to crashes it couldn't prevent. You're not adding, you know, if you've got curved chevrons, it's, it's not applied to crashes that just were completely unrelated to curve. So anyway, that's how you walk through each of the steps and get to a final number. And I am inclined to just pause and check with Adam. Adam, any questions come in or that would be good to address for these 2 examples?
Yeah, I'll try to just do 2 kind of quick questions here. One is, wouldn't the addition of left turn lanes have a larger effect on rear end crashes as opposed to left turning, since now the left turning vehicles can get out of the travel lane?
Yes, yeah, good comment. And yes, they would likely apply to, and that CMF applies to all crashes, so it gets applied to all the crashes. And so when you do the math, you like this here, it didn't apply to all the crashes, but for that one, it does apply to all the crashes, and it would likely reduce rear end crashes as well. And so yeah, I guess kind of in our theoretical example, we're assuming that there's a number of crashes that could be prevented by that type. So, but yeah, it's a good point. You want to think that through?
I think that kind of answers some other questions that are being asked about the application of the CMF. So you have to, this example and the previous example, it's about what the research was based on and the applicability of crash types, crash severity, roadway context, roadway type, or intersection type, as to what the CMF can be applied against. And so there was just, I think, a question about, on that specific example that we used, how we estimated the number of non-applicable crashes. And we just, in this example, are kind of estimating 10%, but you could certainly, in a realistic scenario, estimate that based on the details of the crashes.
Yeah. So there's two things to look at. One is in a situation like this, you'd want to look at your historical data, see and potentially use your historical data to kind of parse out, separate out the crashes by type to come up with that 10%. And there are also so you could apply the historical kind of split of crashes, assume that that's going to carry forward into your predicted, this is a prediction here, into your predicted. There are some predictions that predict different types of crashes as well. Used with caution, it's based on, it's not, you just got to use that with caution. The severity, the predicted severity, folks pay a lot of attention to that, but predictions by type, multi-vehicle, single vehicle and stuff, I've seen numbers that don't necessarily likely reflect the reality of the prediction that we're doing. So there's, you can look at it using the prediction information, or probably better using historical information to get at this part of it and which ones it applies to and it doesn't apply to. Other ones, Adam? I'm inclined to pull up the clearinghouse here. And so you get in here and you've got just, maybe I can make this, I'll zoom in. So this particular CMF here, 0.59, 3 stars, it's applied. These are the crash severities that it applies to, K, A, B, C. And area type is suburban, and it's all crash types. This one down here, 0.68, property damage only. I mean, so you really want to, and this is all, like some of these, like this same research here, Carlos et al. 2017, you want to pay attention to that, and then usually you have to kind of dig in and find out, okay, what did that research really look at, and what should I be applying, and which one of these should I be using? So the bottom one is the all, or do I want to split my crashes and use 2 CMFs instead of 1 CMF? So that I wish it was. Sometimes I often wish it was easier. To do this well is not always easy, and sometimes we underestimate the time that is required to make sure that we get the right CMF. But that's an essential step, just it's worth doing, or you can end up with the wrong, using the CMF you shouldn't necessarily use for that project. Beth, anything to add to that?
No, I'm kind of looking at some of the questions, and one of them is kind of interesting. I don't know how much time we have, but if a confidence interval produces a range of preventable crashes, why not always use the conservative end instead of the average? We don't always have the confidence intervals, but it raises a very good question, right? Because this is an estimate, and that's why you have to, when we do, the devil's in the details, right? You have to look at all the various factors to see what your confidence is in selecting whatever given number, because it could also be the most aggressive end.
There are many CMFs that would go above 1, given the and so it's not a so it is important to think through the context of how you're applying it. What is that, what is your situation? And it may be that that your situation is such that it's best to be conservative, and so you can either, if it's still below 1, you could apply that higher end. You could, we're kind of using, this is an average, but you could pick a different value. It is a distribution. You could pick a different part, a different piece of that distribution. That would take some effort, but you could absolutely pick a different part of the distribution and say, well, I'm going to use something that's at a higher point along that distribution, not the median number. So yeah, there's more and the methods keep developing as the research keeps getting better. I mean, we want to see these the ranges tighten up, and that we want to see the really good research. There is research that is not particularly good that gets done that you want to screen that out. And Beth mentioned the star rating system, and they're going to continue to improve that. And you definitely want to stay away from stuff that has maybe a high range, low rating, and not use those. So good questions. Okay, well, I'll go ahead and move on to the next thing, which is actually a few questions in reverse. So let's turn it around, but we can come back. We got as needed, but let's move on with all right, Beth, now I got to ask you, what am I,
Question
there we go.
22.
So installing cable median barrier reduce crashes by 29%. What is the CMF? And some folks have already started answering. It's live. All right. This time I won't show the answers on screen, realizing it kind of gives away.
Playing rough now.
So installing cable median barrier will reduce crashes by 29%. What's the CMF? All right, so go ahead and bring it over. This is it's 0.71. It's 29% reduction is a CMF of 0.71. It's a multiplier, so multiply by 0.71. All right, let's go on to the next question. Oh, and I got to give you more details. Sorry. This is the setup. All right, so you got the question, but you've also got the setup. For a given observed crashes, the CMF for installing lighting at an intersection is 0.97. CMF applies to all nighttime crashes and all severities. So how many crashes may occur at the intersection after lighting is installed?
This does require math.
Beth, I think you've got the cheat sheet with the answer, right? Go ahead and take your shot at this. It's 0.97 is the CMF, and put in lighting. What happens to the 17 crash prediction, or not prediction, but 17, what would have happened to those 17 crashes essentially if you put in lighting? It's essentially what we're saying. Okay, give everybody about 10 more seconds, 10, 15 seconds. All right, I'll pull over. So this is what everyone answered, and the answer is the 16.91. Does not make a big difference. Well, it does not. The CMF is small, and the number of crashes that are affected by that CMF are also small. It's just the 3 crashes that happen at night. All right, so most of you got that one. Go to the next one. No, that is the next one. Then the last one here. How many K&A crashes would have occurred? So go to the next question. So how many K&A crashes? So 16.91 was the answer, and how many K&A crashes would have occurred if we'd implemented those last 5 years?
So I think that's a multiple choice. So you can probably. Well, you're still playing rough. Yeah, forgot.
Just figured everybody can take their best shot at it, and I think there's going to be. Actually, I think there might be a dispute on this one, but we'll see.
I think I just realized what it might be. This does, though, address one of the questions I saw in the chat pod about, pulling out the crashes by type. You want to apply the CMFs to just those crashes for which the treatment is aimed. If I said that, I may have said that in kind of a convoluted way.
I give you about 5, 10 more seconds to go ahead and answer. I appreciate everybody's taking the time to answer. Go ahead and pull it over here. This is we got we don't know, and some said approximately 2, 1.94. So the majority said we don't know. Next is approximately 2. We know that in our data sample there were 2, and so we didn't have information about whether or not those occurred at night or not. So the kind of initial we don't know is accurate in that we don't have that relationship. However, if you were to assume kind of proportionality, you could say, well, 2 of the 17 were KA, and so we know the relationship, and so we could estimate, we can make an estimate based on that information. It would be better, though, to know whether or not those 2 K&As, to have this as a cross tabulation, were they daylight or darkness crashes. But that's, yeah, so I, at this point, I would say, we don't know, we need to go find out how those crashes, when they occurred, but the approximately 2, 1.94 is not necessarily wrong. It's just you're kind of using an assumption, and which we often have to do, and so make sure you document that assumption. I know this is a small number exercise here with just a few crashes, 3 and 2, but you end up with the same situation with larger number of crashes, and document those assumptions. If you take develop some ratios and you apply them, make sure that goes in your PD&E documentation quite clearly. This is what we had available to us, and this is what we did with it. These are the assumptions. This is how we applied them. So, all right, very good. So something of just a thought exercise there. Go ahead and move on to the next question here, which is a treatment has a CMF of 0.87 and a standard error of 0.15. What's the possible range of the CMF value? And Open it up to voting here.
More math.
A little bit more math.
You checking my math, Rob?
Yep.
Good.
Oh, and I should have said, I'm sorry, so this might change some of your answers. 0.9, we're going to use the 95th percentile confidence interval that Beth talked about before. So I should have said that. I apologize. Should have put that right on there.
Yeah.
Yeah, so use the 95th percentile confidence interval. All right, so I am, Beth, going to let you, unless I'm mistaken. So this is what we've got for answers thus far. And unless I'm mistaken, I'm getting the wider range there.
Yeah. C. 0.57 to 1.17.
Right. So that's 1.167 if you use 1.98. So it ends up with a pretty big 1.15 is kind of a biggish standard error. And so I'm inclined. I'm just going to kind of scroll. No, I won't scroll back, but it's 1.98 times that standard error is the plus or minus to get your interval. So it's 1.98 times, in this case, 0.15. And that gives you, add that to the 0.87 and subtract it from 0.87, you get a pretty big range, and that's kind of a giveaway for the next question. But will there be a change in crash frequency at the site if the treatment is installed? This goes to one of the comments that folk, that was asked earlier that Beth brought up. It's a real thing to think about as you're doing this. Yeah, so I see most of you, got that, and so we've kind of set it up. Sorry, softball there, but crashes could increase or decrease. So that is, that is the reality for some treatments. We don't know. Not every treatment is a sure thing going to improve safety, and so we need to go in with that skepticism. Well, I'm not sure if this is going to work to help us with this problem or not, and then think it through and come to good engineering decisions based on the information that's available. So in this particular case, it could be it might not help us.
And we often, first with CMFs and other analyses with the HSM, we often wind up kind of bracketing solutions, like Rob described earlier, where you look at it from a couple of different angles, look at it the low and the high end. Just because of that uncertainty, it can be hard. So don't be daunted. Consider multiple angles and then document.
Yep. All right. Well, it's around just a little after 4:30, and we've got one case study and then a little bit of wrap up. So we will end before the hour. So, but this next case study is going to be a little bit of live CMF online, looking, and so we're going to use diverging diamond interchange as our example. So this is the situation. We have a standard diamond, and we're thinking about converting it to a DDI. The standard diamond prediction is 140 crashes over 20 years. how many crashes would we think we'd have with a DDI? And in the current equations, there's nothing, you can't put something in there. You've got to use a CMF. It's not in, there's no safety performance function for DDI interchanges at this point. So we got to go hunting for a CMF. And so go ahead and if you've got I'll just tell you right now, I've provided we've provided 2 files that you can look at, but I'll also be opening up the clearinghouse on my screen, and I would encourage you, you might want to just open up and do this in the clearinghouse. But I'll show these files. I don't want you to get tangled up with the 2 files, but I wanted to provide them to you, and then I will pull up the spreadsheet, which says it's CS3, all 60 CMFs, and we're going to pull up these 60 CMFs in just a minute in the clearinghouse. But literally, we've got a spreadsheet here, and you can download all this information. And so these are the kind of the 60 DDI, and there's lots of information in the spreadsheet. And we're not digging into all of that. I just want you to know that you can download a lot of information from the clearinghouse, as well as, like I said, go and find specific reports. And some of these reports are actually publicly available and pretty useful. And you know, this would be an important project decision, right? You want to make sure that you've done the required homework on this one before you make a decision to go and implement this project. So the other thing that we've provided here is, let's see if I can pull over the is kind of a file that shows some of the finalists. So it's another file that's kind of an offline file. We'll go into the clearinghouse and look at this, but I just wanted to see you can kind of pull this offline. You can put pull documentation out, put it into your appendix, or however you need to do it. There's a lot of information out there. So let's dive in though and go into the clearinghouse itself. And actually, I've already got it open, but yeah. All right, so got a clean start here on the CMF, and I'm just going to type in. You can see I've done it recently, right? DDI, and hit search, and it will pull up some bicyclist, interchange design, intersection geometry, intersection traffic control, roadway. I'm interested in this interchange design one, and there's 60 of them. And so I decided I'm going to go in here, and 60 is a pretty big number. I'll admit, first time I did this, I was daunted. Okay. Now look at this first one right here, countermeasure, convert at-grade intersections to diverging diamond interchanges. Well, I don't have an at-grade intersection. Yeah, I don't, this isn't me. So I'm gonna go past this one. This one is convert interchange, diamond interchange to either DDI or double crossover diamond. So this is me. I want these 58. So I've gotten rid of 2. And I open this up and I think, okay, where do I start? And I look and I see that some of them, so I kind of scroll up and down, I've got some in here that are 2 stars. Well, I don't really want any 2 stars. I also see that some apply to only single vehicle, side swipe, rear end angle, and some apply to all. I want it to apply to all crash types for sure. So let's go over on the left here and say I want only those that apply to all. And up at the top, I only want star ratings of 3 or more. Filter my results. I'm down to 14. These 2 still get pulled, but I've got 14 now. So I've gone from 60 to 58 to 14. And then I look at crash severity. Well, I want the all crash severity. I don't want just the high severity for what I'm doing at this point in the project. So I'm going to go and I'm going to click all. I'm going to filter my results again. Starting to narrow it down. So now I'm down to 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've narrowed it down. And so that's one way that you can really kind of narrow this down. And what you might notice is that there are 7 of them that are all from the same research. They're all from the same piece of research. They all apply to all, and so you're like, well, what gives? I got, you know, widely varying stuff here, and it's all from the same research. And you clearly cannot work from this page. You can't just pull a number right off of here. If you pull a number off from here without digging in on it, I mean, you could pull the 0.328 or the 0.64. I mean, the numbers are all over the place. So when I look in here, I looked at this, and I actually went and pulled this piece of research and found out that, in fact, there were many states. So I think there were nine different states, and each state had a different number. And and when they pulled into the clearinghouse, they pulled in the values for each state as well as the value for the research overall. And so that really makes it harder. Yeah, so 26 DDIs in 11 states. And so it just we ended up with a lot of different information. But you see, this study recommends a total crashes CMF of 0.633 based on comparison groups of 26 DDIs in 11 states. So that is the number I'm actually kind of looking for, and it's this top number here, which was all states. And so if you dig into these different things like Beth showed you, it'll list down here which are the states. And so we've got, you know, quite a number of crashes, quite a number of locations, and a lot of states and a lot of years. And so it's a pretty big data set. But I don't want the value just for Wyoming. I want the value for the research as a whole. And I will point out that Florida, and there's no Florida data in here, so it's not in this research. So, you know, I certainly don't want to pick one state that isn't geographically representative. So that's kind of the work that we did, and I'm going to go back to the presentation, and you go through that, and we ended up with picking 6 possible CMFs. So I skimmed through, and I'll show you down here on the lower right, why doesn't 6 match what you saw on the screen? Well, this is why you keep digging. Crash severity was blank for 3 of them. And so at the time, anyway, that I pulled this information, crash severity was blank. Well, I didn't check the literally not specified for crash severity. And they're not, you know, so at the, you know, so you can miss, so you got to kind of really spend some time with it. So we ended up with 6 that were possible. They're kind of in the same general range, but when we dug into them, we realized that number 2 had a small sample and was included a state that was included in the one I just showed you that had all those states in it. So the data was probably included in the other study, and this was a very small sample. Number 4, similar, small sample, likely included number 5. Number 6 looked like it had a small sample, likely included number 5. Number 3 applied only to the ramp terminal, so that isn't what I needed. So I basically was able to eliminate those, and what I was left with was study number 1 and study number 5 that had similar numbers. They both looked like they could be good, and I'm left with another decision. Do I pick one? Do I average them? Do I pick the higher one? So, and that may be the way I should go, is use 0.67, the higher one, although the study number 5 kind of swayed me because it had such a large sample and was so recent. It was more recent. So given that information, the decision was made here. We're going to take the average of these 2. We'll document all of this that we did, that we got us to these 2 studies. We used these 2 studies. They are in the same kind of order of magnitude. And then if we, in the course of the study, we may decide to do the bracketing to say, well, it may be between here and here. Maybe we want a range. Again, it's an important decision. This is a starting point. Oh, let me go up and exit out and just bring that over. I want to show you because I want to get underneath those those items that I've got there. So what's under here is that the standard error is pretty low. This one was 0.008, and so that's pretty low standard error, lower than this other 0.04. But we could apply those standard errors. We could come up with ranges, and decide that we want to maybe report that the predicted crashes are going to be somewhere. We think they'll be somewhere between X and Y, and so there's more to be. This isn't the end necessarily, but this gets us to for this example, a stopping point, and allows us to go over, so what the number would be. 140 times 0.65 is 91 predicted crashes over 20 years, using that information I just showed you, and that kind of line of thinking and that research, with the benefits and drawbacks of the research that's available to us. So that is that kind of gets us to the end of this example. Beth, did I skip over anything? And Adam, are there chat questions?
No skipping. Adam, any questions we should consider?
Okay, not hearing anything. I
do see, somebody
Sorry,
suggested.
yeah.
Oh, go ahead, Adam. Well, I was going to say, I see that somebody suggested a sensitivity test for all three values. Absolutely.
Yes.
And that's, it's as we've said a couple of different times now, you got to kind of look at it from all the different angles, and kind of bracket the solution. So absolutely.
Yep, good comment. Yeah, we're simplifying this down a little bit, make sure we get through examples, but thinking hard about this is essential to doing this work well and not overestimating or underestimating. But certainly, try not to overestimate the benefit that you're going to get from safety benefit you're going to get from a project.
So another question, which is probably applicable, is if you don't have data for all your alternatives, can you blend different approaches?
Yeah, yes. So, for example, let's say that this interchange was being reconstructed in the middle of a freeway project. This is a prediction. The segment analysis for the freeway wouldn't necessarily use any CMFs. It might be all based on the predictive method, and not need to apply a CMF. So this actually, if you use IHSDM or ISETI, the two software tools that are used to carry out the Highway Safety Manual's predictive method, both of these become kind of, in IHSDM you can put the number in there, but it's kind of in addition to. But yeah, you can combine, so this gets layered on to prediction equations. And there are situations where you can maybe predict something, and then you have to use a CMF with historical for something else. Yeah, sometimes you end up, due to limitations of the prediction equations, maybe they don't apply to a facility that you're going to study. You're going to study a facility, and there's no equation for it. I mean, up until recently, that was the issue with one-way streets and 6-lane arterials. There wasn't an equation for them. It still is the issue with, say, a 12-lane freeway. It's outside of the bounds of what you're going to do, and you got to decide what you're going to do. You got to make decisions about, do you stretch do you go beyond what the research was developed for? So, or do you use a CMF or something like that?
So one of the other questions that's kind of been a theme for predictive analysis is the consideration of traffic growth. So applying CMFs and doing this type of analysis. Yeah, just is that being considered? Should it be considered?
Right. Yeah, so in this example, the traffic growth is baked into the predictions. It's assumed that we did these predictions with traffic growth and use safety performance functions to get these predictions. So it's kind of baked in here. You see, if I go back to the prior, it's a few slides back, apologize. Here, I said assumes no traffic growth for this left turn lane example where we applied the CMF. And, you know, if we had 5 years of historical data, and that's why I kind of caveated this with we're just looking at we're kind of looking at the near term, next 5 years, no traffic growth, last 5 years, next 5 years, maybe, you know, we can say that applies. But if you want to try to use that to predict forward, you would have to increase your exposure and make an explicit assumption that that the crash rate essentially stays the same into the future.
Right.
And so as growth, you know, as traffic increases, the crashes increase, and you apply this proportionally. Beth, what are you?
Yeah, I agree. In short, you do want to account for growth in traffic because we know that's one of the biggest drivers of crash frequency. So when things are going easy capeasy, you have a predictive method. The equations are applicable. You grow your traffic volumes within the predictive method, and we'll show that tomorrow. When things aren't, then as Rob just said, you might have to fall back to, well, we don't have a predictive method right now. We can use crash rates, and we're going to assume that the you know, in the next 20 years, we would expect a similar crash rate. Now, that may not be great, but short of not doing anything, it's better. And so it's reveal the caveats, document it to the extent that many of these details can be discussed and confirmed in scoping. That's great too. But in short, yeah, we do want to account for growth in traffic volume.
So using this example, if we assumed that the next 5 years had literally twice the traffic, then we would expect twice the crashes, and our reduction would still be 29%. It'd be a 0.81 multiplier, but you know, the exposure, right, you definitely want to take that into account. And so we would end up with twice the predicted crashes. The reduction would still be the same, it's proportional. Yeah, you want to think that all through and then determine what the resulting crash rates are, because you've got your baseline no build crash rate, and then you've got your crash rate that takes the CMF into account. And we'll get into it tomorrow that using crash rates to present your results is very helpful. You want to present both crashes by severity and crash rates by severity. So good questions. Anything else, Adam? I'm watching the clock. Beth, I need to turn it over to you.
Yeah, we'll do the big wrap up. Let me get my screen set up.
Yeah, so we're also watching the clock. These are the last couple slides here. So just the key takeaways and wrap up.
Yeah, let's just do them from your screen, Rob.
That sounds good.
All right, so takeaways. CMFs, they're multiplicative. They tell us what an average change in crash frequency or severity might be when attributed, which we can attribute to a particular treatment. And we use the word treatment and countermeasure interchangeably. You got to watch out for the base condition and the context and the crash types that the treatment and the CMF are applicable to. The devil's in the details. They're an estimate. They have a standard error. Think about the ranges and the confidence interval if that's available. Think about that as particularly given how well the treatment does or doesn't fit your context. Less than 1 is good for the CMF. Greater than 1, take a look. You might be increasing crash frequency, severity, or type. Next slide. So just some tips, and I kind of went over those a moment ago, but verify that, do the digging that Rob showed you. Verify that the base condition and the context and the study are applicable to what we're doing. And as we said, when you go into the clearinghouse and you see, if you get, first of all, if you get 1 number out of the clearinghouse, you're a lucky person. But even so, go in and dig to make sure it's applicable. And verify that it's applicable based on the base condition, the crash types, the severity you're thinking about, and consider how it was developed. You know, you're taking from the Highway Safety Manual, the star rating, and the clearinghouse. Take a look at independent research. Verify independence if you're going to apply more than 1. Next slide. And document, document, document. The source, so if you're using a CMF from the clearinghouse, record the ID number and the star rating. It just makes everyone's life easier in reproducing your results. If you take it from the HSM, document the table. And certainly if you're using research, you know, the details of the published research. Always record the base conditions, the caveats, the consistency. Again, we're trying to help someone else go, yeah, you know, that person's judgment was good. I like that. I can agree with those assessments. And of course, you're going to document the potential impacts that can be associated with the treatment. So document, document, document. And that's it. So again, hopefully we've given you some insight into integrating safety into PD&E. There's that existing conditions assessment to figure out, should safety be a primary need? And also to figure out what trends we should be thinking about in our alternatives investigation, which I can't say. The guidebook is consistent with F.HSM implementation policy. That existing conditions assessment drives whether or not safety should be in the purpose and need. And CMFs are a tool, obviously, and the clearinghouse is a great resource. And the devil's in the details. I'll say it again. You got to do your homework and your digging. And I think that's it.
That's it for today.
Awesome. So tomorrow you will all come back just as excited. And tomorrow's all about the predictive method. So unless there's any outstanding questions, we're going to let you go home and have a good evening.
Yeah. Thank you all very much for attending.